In this tutorial, I'm going to take you through the two Catchoff laws, that is the Catchoff Current Law and the Catchoff Voltage Law, since they form the basics for all network analysis. If you are new to this channel, I will urge that you will subscribe and put us on post notification so you get notified when we upload relevant engineering concepts. Now back to today's video. Suppose we have a question in this form for a Catchoff current law. This law states that the sum of currents that are entering into a node is equal to the sum of currents that are leaving that node. So from this question, we can see that current 3 ampere, 2 ampere and I ampere are entering the nodes, and current 7 ampere, 5 ampere are leaving the nodes. And so to find I ampere, we add the currents that are entering the node and we equate it to the addition of the current or summation of the current that are leaving the nodes. So we have 3 plus 2 plus I is equal to 7 plus 5. And this is going to give us our I to be equal to 7 ampere. Now pause this video and try your hands on the second question. So when you solve the question, you are going to get I to be equal to 1 ampere. Now let's move on into the Catchoff's voltage law. The Catchoff voltage law has a lot of technicalities behind it. And the voltage law states that in a closed path, the algebraic sum of the voltage sources equals the algebraic sum of the voltage drops. What do we mean by voltage sources? The voltage sources are the batteries and things that offers voltage to the circuit. For example, in this case, these things. These are the voltage sources. So the voltage sources, the summation of all of them will be equal to the voltage drops across all the resistors here. And with Catchoff laws, we have to traverse in a particular path, and that path is going to determine our sign convention to use. So when, for example, we traverse in the path A, B, G, H, A, in order to know the sign of the voltage that we are supposed to use, this really confuses people, but this is what you are supposed to do. In order to know the current that you are going to, or the sign that you are going to need for V1, this is what we do. The last part or the last sign that the current will touch will be the sign of the voltage. And so for this, we can see that A, B, G, H, A. And so the last part the current will touch is going to be the positive terminal of the battery or the voltage source. So it will move from this resistor to this resistor, to the negative terminal, then to the positive terminal at last, then to come to E back. So the voltage, when we are traversing in the direction A, B, G, H, A, the voltage is going to be positive V1, and that will be equal to the voltage drop across resistor 1 and resistor 2, which is I1 times R1. So I1 times R1. Then we have plus I2 times R2. Now the reason why we used a plus is because the current moves in the direction of the loop that we are choosing, or the direction that we are choosing. The current moves in the same direction, and so the current will be positive for both resistors. Now let's traverse along A, D, E, H, A. But before we do that, let me explain this diagram. Now suppose we turn this voltage upside down as shown in this diagram, and we move in this direction. The current is going to touch the negative terminal last, and so it will move from resistor 1 to resistor 2, then positive terminal to negative terminal, and so for this the voltage will be equal to negative V, which is equal to the voltage drop across the two resistors, that is I1 multiplying R1 plus I2 multiplying R2. So let's come back to the question. Suppose we are traversing along A, D, E, H, A. A, D, E, H, A. Then for the first voltage, since we are moving A, D, E, then for this the current will touch the negative terminal at last for V2, and so V2 will be negative V2. But for V1, it will touch the negative terminal first, then positive, and so V1 is positive V1, and that will be equal to the voltage drop across resistor 1, resistor 3, and resistor 5. And so we are going to get I1 R1 plus I3 R3 plus I5 R5. So this is also an equation that we can get from the Catchoff voltage law. Now, thank you for watching to the end of this video. We will be uploading a video where we will solve questions based on the Catchoff voltage law. Do well to like, comment, and subscribe to this channel, and recommend this video to your friends who have difficulty in understanding the Catchoff's law. Thank you for watching.